Welcome, everybody. In the last section, we talked a lot about terminology, the language of statistics, what data looks like, what data actually is. What we want to do now is turn our attention to describing that data. What happens when you have a set of data? Are there numerical descriptors you could use for it? Are there graphs that you could use to describe it? And that's really what we want to address in these upcoming few sections, is the graphical nature of the data. If you have some data, is there a meaningful way to display it graphically? And so let's start by posing this question here. We have a set of Lakers scores. And these Lakers scores are from, I don't know, several years ago, but there were sample size of 30, taken in a very non-scientific way, but here they are. We want to organize the data meaningfully. And so when you look here, we have some definitions, again, that we want to get out of the way. First is a frequency distribution. First and foremost, a frequency distribution is a table. It shows classes or intervals of data entries with a corresponding count of the number of data entries in each class. This count, just think of that as a tally, okay? It's just a tally. The frequency of a class is the number of data entries in the class. Again, think of it as a tally. Relative frequency. You have the frequency, but then we're dividing by the size of the data set. So this tells us relative to all of the data, what is the frequency of this particular class. Cumulative frequency, which we'll get to in a little bit later, is the sum of the frequencies of each class. It's kind of a running total, so that by the time you work through your last class, you've accounted for all of your data, and that last cumulative frequency will be actually your sample size. Then we have our lower class limits, upper class limits, and class boundaries. So the lower limits, that's the smallest value that can be in a class. Upper, the largest or greatest value that can be in a class. And then the boundaries are used to separate the classes. When we talk about histograms in a few moments, we'll spend some special time describing the boundaries and what they mean. So how do we proceed? Well, when you construct a frequency distribution, first issue is the number of classes. Typically, the number of classes will be in the, I don't know, 5 to 10 range. There's a formula, rather moderately complicated, that you can use to determine the optimal number of classes, but typically 5 to 10 does everything we need. Again, the point here is to just get a graphical or even a pictorial description of what our data looks like. And so you can get that whether you use 5, 6, 7, 8 classes typically. So general rule of thumb will be somewhere in this range. Then we want to calculate the class width. So you've got your max minus your min divided by the number of classes. Now, a couple of things to keep in mind. The number of classes is for you to decide on. If you are trying to crunch some numbers and you're trying to explore some data, you might decide what the right number of classes is. Now, from my perspective, having to present this to a large number of students, if I want some uniformity, I might actually typically give this to you. So a lot of times I will give you the number of classes, but in the real world, it's something that you would need to hash out and decide what's appropriate. Also, that is not an equal sign, folks. That means approximately equal, and really what this tells us is that we can choose conveniently. Choose convenience. So if I have a class width that comes out to 3.7, when I compute it using the formula, I'm going to call that 4. Why is that? Well, frankly, I would rather count by 4s than 3.7s. And furthermore, what if it came out to be, say, 3.2? Well, for 3.2, you would also round up to 4. So as a general rule of thumb, when you're finding these class widths, you want to round up. Never round down. What happens when you round down is you wind up having data that's outside your intervals. That's no good, right? We've fixed the number of intervals we want. We want to make sure all our data fits into one of those. So if you round up, that'll do the trick. Well, once you've established that class width, you're going to choose your first lower class limit and then use that class width to get from one lower class limit to the next. And same with the uppers. Once you've got your classes, now it's just a matter of looking at the data and tallying it. Okay, so where are we? We want to look at that Laker data. And we want to build a frequency distribution for it. And I've gone ahead and included the other frequencies we mentioned here. So the raw frequencies, the relative, and the cumulative. But first, we need to notice the number of classes. So if we just go by number of blanks here, let's see, 1, 2, 3, 4, 5, 6, 7. So we have 7 classes. So once we have our classes, now we need to decide on the class width. So the class width, again, is going to be the max, whoops, minus the min, in this case, divided by 7. And then we're going to round that up. So what I want to do now is get my hands on the data. Now, I'm sure we could all put things in order from least to greatest, but that's cumbersome. This is only a data set of 30. What if we had 100 entries in our data set? It gets cumbersome very quickly. So what I would encourage you to do is pause the video and then open up Excel or whatever your spreadsheet program is. I'm going to be using Excel. And input this data. I've already done that, so if you wouldn't mind just pausing it for a moment and then inputting that data. So I'm going to step aside and let you do that.